This video is about the beginning of factoring. At the end of the last chapter, we did factoring with the GCF, which we're going to review, but today, after that, we're going to focus on the difference of two perfect squares, and we're going to look at a little bit of other factoring. So, to look for a GCF, you are looking for the biggest number that is a factor of both 7 and 21, and that is 7. And you're looking for the variables that they share. So, these each share an A. They do not share two A's or an A squared. They each share an A. There's not a B in both of them, so the 7A is your GCF. You write it out in front of the parentheses. And then what you're doing is you're going back and you're dividing each of these by 7A, and you do not have to show this division if you can do it in your head. But when you divide here, you're dividing the 7s, you're subtracting the exponents. You're dividing the 21 and the 7, and the A's cancel, and you get B. You do not need to show this part, but this is your answer, and the 7A has to be out in front. Here when we look, we are looking at 18, 36, and 6, and the GCF, or the largest thing that divides in, is 6. And they all share an X. They do not share two X's, or X squared, they all share an X. Now I need to go back and divide each of these by 6X. And again, you're dividing the coefficients and you're subtracting the exponents all the way across. Be careful on this. 6X divided by 6X is 1, and you have to have the plus 1. Here the GCF for 25 and 50 is 25. That's the largest number that divides in. X to the 4th is what they have in common. Y to the 1st is what they have in common, and they do not have a Z in common. So if you haven't thought about this yet, it's really the smallest exponent that you're using as long as it's in both. That's what's part of the GCF. So now when I go back and divide by 25 x to the 4th y, I get 1y squared, and if you want to write a 1 there, that's fine, plus 2xz. And there's your answer. These look a little different, but here's what you're looking at. These two terms are separated by plus and minus. They both have a 2x plus 7 in them. If you covered up the 2x plus 7s, there is an x plus 1 left, and you have to write that in parentheses. And if you choose to write the x plus 1 first and the 2x plus 7 second, that's fine. You can do it that way, but that's your answer. So here, what these two terms have in common is an a minus b, and it has to be in parentheses. What's left, if you look around or cover up the a minus b, is a minus 3. And again, you can change the order like we did on this one. Here, what these two have in common is e plus 9. If you factor the e plus 9 or you look at what's left, it is e minus 1. So, what you need to do is turn off the video and quickly do this review. That's what you would be doing in class, doing this 6 really quickly to make sure you know what's going on there. So stop the video, then turn it back on and see if you have them right. So I'm just going to quickly write down the answers and not talk about them. Make sure you have the minus 1. There's no B there. There's your answers. Oops, sorry, there's your answers. So now, I want to look at the bottom. This we have not done yet, but it relates to something you memorized earlier, and that is, this is about what's called the difference of squares or the difference of perfect squares. So when we look at this, Do you notice all of these have a minus in them? And that's what this word difference has to do with. That this is about subtracting perfect squares. Lots of teachers talk about it a little differently or try to get you to remember what it looks like. I just say, does it fit the pattern of a perfect square minus a perfect square? Because if it does, it factors pretty nicely. So you're going to make two sets of parentheses right next to each other. You're going to put x here and x here, because if you think about foiling or multiplying these together, you get x squared. And that's a perfect square because it's plus 8 times negative 8. It's 8 times 8, and one has to be positive and one has to be negative. And if you think about multiplying or foiling this back together, you would get that. Now, I'm not going to do this on every one, but you could write the x minus 8 times x plus 8 in that order. That would be the same thing. So I look and I notice this is a perfect square minus a perfect square. And I put the y's in, and that's a perfect square because it's 6 plus 6, and I need a positive and a negative to multiply to a negative 36. I'm going to work down these two columns. So the difference on 17 and 18, then on 13 and 14, is that the variable is in the back side of the problem and the number is on the front. And here's how that changes how you write your answer. Since the 25 is first, the 5's go in front of the parentheses, and since the e is last, the e's go in the back, and you're multiplying to a negative e, so you need a positive e and a negative e. Again, if you want to write 5 minus e first and 5 plus e second, that's fine. So now, if you don't know if 361 is a perfect square, you've forgotten, you can check by doing the square root of 361 on your calculator. It is 19. That's one of them you memorized. So you have 19 plus x and 19 minus x. You may not switch the order of this. It is not okay to write x plus 19 and x minus 19. That is not okay. Those not the same thing, because you're multiplying to a negative x squared, so you need a positive x and a negative x. These two are also the pattern of a perfect square minus a perfect square. I need m times m, and I need n times n, and I need a positive n and a negative n. Here I have x times x and y times y. I need a positive y and a negative y. If you were to FOIL those back together, you would get back to this original problem. So now, there's more numbers and letters here, but we still have, if you think about it, we have a perfect square minus a perfect square. To get multiplied to 9r squared, you need 3r times 3r, and 1 is a perfect square because it's 1 times 1, and you need a positive and a negative. To multiply to 4m squared, you need 2m and 2m, and 3 times 3 is 9, and you need a negative 9, so you need a positive and a negative. So 4x squared is a perfect square because you can multiply 2x by itself, or 2x times 2x. 121y squared is a perfect square because it's 11y times 11y, and you have to have a positive and a negative to multiply to negative 121y squared. And these are both perfect squares, so I get 3v plus 15w and 3v minus 15w. And you may have to think about it for a moment longer than I do, but that's the idea. So you need to turn off the video and quickly do this side. These follow this, and make sure you know what you're doing. So check your answers. I'll just say this one time. If you wish to have m minus 10 first, or that's how you wrote it, and m plus 10 second, that's fine. So if you look, I'm just about done. This is called factoring. So you have factored the difference of squares, or you've factored the pattern where you have a perfect square minus a perfect square. So, next page. So now, we're going to combine the two things we just did. There is a very first rule of factoring. And the first rule is to take care of a GCF. So we're going to look and notice there is a GCF here. It is 2. So I have to factor out the 2. And what's left when I divide these by 2 is x squared minus 25. So I have a GCF. Now I have to notice that this is a perfect square minus a perfect square. So it's 2 steps, and the GCF is first. The GCF comes down, it's part of your answer. But the factoring you're doing now is this perfect square minus a perfect square. So I need x times x and plus 5 and minus 5. And that is factored. So when I look here, I have a GCF. It's not a number, it's x. There is an x in both of those. If I divide out the x, I have x squared minus 529. Now, you're going to have to check 529 because it was not one we memorized. But if you do the square root of 529 on your calculator, you will get 23. So it is, in fact, a perfect square. So this thing fits the pattern of a perfect square minus a perfect square. So I bring the x down. You have to include it in your answer. I make my 2 sets of parentheses, and I have x plus 23 and x minus 23. So on 37, I'm looking, and I have a GCF of y. And if I factor it out, I have x squared minus 625. And 625 is a perfect square. You can check it the same way. You're going to put the square root of 625 in your calculator, and it checks. It's a perfect square. It's 25 times 25. So I have x plus 25 and x minus 25. Now, 38 is a tad bit tricky because these are in fact both perfect squares. But the first rule is that you have to look for a GCF. And there is a GCF here. It's 4. And if you divide 196 by 4, it works out nicely, so that is what you have to do. And you get x squared minus 49. This 4 has to be out in front, and that factors to x plus 7, x minus 7. Make sure your GCF is included in the answer, so stop and try those 4 very quickly. If you check 484 is a perfect square, it works. It is 22, so I have x plus 22, x minus 22. Make sure your GCF is out in front. So now, the last part is a little different. We're going to go back and look at that you know how to FOIL things in your head. We practiced multiplying less than or this 2. We practice multiplying those in our head. And we're going to use that idea in figuring out how to get 2 binomials. So this is a binomial. That's a binomial. To multiply to this trinomial. Here's what I want you to notice here. These all end in a 24 or a negative 24. So we're looking at the numbers 24 and negative 24. And I just, 24. For this moment, we're going to write 24 down twice and negative 24 down twice and look at this thoroughly and then realize we can consolidate in the future. If I want the numbers that multiply to 24, I can use 1 and 24. I can use 2 and 12, I can use 3 and 8, or I can use 4 and 6. And you can use your calculator to come up with those, but you might know those in your head. The other way I can multiply to positive 24 is to have 2 negatives. Like I said, we're not always going to make all these lists, but I want you to see you can use 2 positives or you can use 2 negatives. To multiply to a negative 24, I can have a positive 1 and a negative 24, or a negative 1 and a positive 24. So if I make this list accordingly, I'm going to leave the first number positive, and on this one, I'm going to leave the second number positive. Now, what we're looking at is our factors. Factors are things that multiply back to that number. So 2 and 12 are factors of 24. 3 and 8 are factors of 24. These factors right here, these factors, if you add them, add up to 25. And these factors, if you add them, add up to 14. And these factors add to 11, and these factors add to 10. These 2 factors add to negative 25, these add to negative 14, these add to negative 11, and these add to negative 10. So they multiply to the same number, but they add to different numbers. Over here, these add to negative 23, negative 10, negative 5, and negative 2. These add to positive 23, positive 10, positive 5, positive 2. So now, on all of these trinomials, you're going to make 2 sets of parentheses. So if you wish to do that part first, you can. The first 2 things you put in the parentheses are x and x, because if you think about multiplying, that's what's going to multiply to x squared. And you want 2 numbers that multiply to negative 24. You are always finding numbers that multiply to the last number. So it's numbers off these 2 lists, but you want the 2 numbers that add to positive 10. Or if you think of it as subtract, that's fine. But I'm looking across this list and saying the 2 numbers that multiply to negative 24 have to be here, and if they add to 10, they have to be here. So I need a negative 2 and a positive 12. And I want you to realize you don't really need these lists all the time to come up with some of the answers. You'll know them in your head sometimes. And if you want to write x plus 12 first and x minus 2 second, that's the same thing. That's okay. So now I'm multiplying to positive 24. If you're multiplying to positive 24, it's off these lists. And if you want them to add to a negative, it's got to be here. So I am adding here. To multiply to 24, and it's positive, and to add to a negative, I need 2 negatives, so negative 1 and negative 24. Now, if you're thinking, okay, this is nice, I can just look on this list, you're not always going to have room to make lists on all of them. I want you to see what's happening up here, and I want you to kind of think about, I'm multiplying to a negative 24. To multiply to a negative, you have to have a positive and a negative. And then I need numbers that when you put them in here, add or subtract, I'm going to use the word combine, that means add or subtract, to negative 2. And you can find that on your list, but you can also think in your head, that's got to be a positive 4 and a negative 6. Now I'm multiplying to a positive 24. To multiply to a positive, you either need 2 positives or 2 negatives, and in this case, it's going to have to be 2 negatives, and I get negative 6 and negative 4. So, you need to turn off the video and you need to finish these and then come back and look. So I'll just mention one more time on the very last one. If you ended up having x plus 3 and x minus 8, that's perfectly fine. But you have to have one of these two. You can't have anything else. These are the two numbers that multiply to a negative 24, and they combine to a negative 5. And if you actually FOIL this together in your head like we practiced, you would get that. Now, one thing I want to point out on this one. It is easy sometimes to look at this one and think about 12 and 2. And although this would give you a 10x in the middle, it would not multiply to a positive 24. That does not work on that one. So you have to actually do the check of how does it multiply back, and am I picking the right numbers? Thank you.